little bit about it. Okay, so we might as well get started. Let's take a look at arrayReplace, and yeah, we'll start there. arrayReplace. Here we go. All right, so we're being given an array in this problem, and we want to replace all occurrences of element to replace with substitution element. Okay, so sounds pretty straightforward. I mean, in the example, they give us 121, or sorry, 121 as an array, and they're saying we want to replace the 1, we want to replace it with a 3, and notice it's not just like the first one, it's all of the ones. Okay, so we'll do this in a few ways. I mean, I guess we might as well start by just doing some kind of a for loop solution, you know, something that just goes through and checks if the element is equal to lm to replace, and if it is, it'll just replace it with substitution element. So we'll say for let I assign the value of 0, I is less than input array dot length I plus plus, and then basically we could say something like if input array at I is element to replace, if it is the thing that we're looking for, that we're trying to replace, then under that circumstance we'll say input array at I is assigned the value of substitution element. And then at the end we can just return input array. It might seem strange that we're returning the input here, but we've modified it. We've mutated the array, and so we've changed some of the values in there. So let's see if that works. We'll run the tests on that, and we'll see if it's solving the problem the way we want to. It might take a little minute, and maybe this is a high traffic time of day, so some of the tests take a little while to run, but there we go. Check marks all across the board. It's passing all the sample tests. Well, is it going to pass the hidden tests? Let's try submitting. And while we wait for those, let's just sort of think about this, and we'll try to consider if there's another way of doing it. Oh, great. Look at that. Okay, so that passed all the hidden tests, all the visible tests. That wasn't too tough. But, you know, we're looking at this and we're thinking, like, we had to run through this whole for loop here. We basically went through the whole array, and it kind of seems like a lot of work for something fairly basic. You know, it seems like the sort of thing that like maybe there's a built-in for, right? I mean, we've got map, filter, reduce, like we've got all these nice array built-ins, and so could we just do something like this? Like, instead of all this business, could we have just said something like return input array dot replace, and then element to replace and substitution element? Like, would something like that work? And I guess I'll spell replace with an A. So there we go. Would something like that work? Is this a built-in? Is this something that we can do with an input array? And it turns out no. Input array dot replace is not a function. Okay, so well, we could do something that we've seen before. We could say let's make it a function. So we'll say array dot prototype dot replace is assigned the value of function, and it's going to take in two things. So it'll have a target and a replacement. So target is basically going to be the thing like lm to replace, and then the replacement is the substitution element. Okay, so basically, how's this function going to work? Well, it's basically going to do what this did, except slightly differently. It'll say for let I is assigned a value of 0, I is less than this dot length, and I plus plus. Why this? Well, we're affecting the prototype of array. Basically, the idea is that this is going to modify our constructor for any new array that we create, or any array that's involved in the problem. Like input array here, we'll now have this additional method on it called replace. So when we say this, we're just talking about like that particular instance of the object array. So input array is an array. It's not like the object array, like the Platonic form array. It's just an instance. It's one array. And so it'll have this replace method. Anytime you see this, it's just whatever particular instance we're talking about. So if we're calling dot replace with input array, then this would be input array. Okay, so this is a keyword that we use a lot in objects. And it can be a little bit mystifying. It has to do with binding. So there's this whole .bind thing that you might end up using later, I guess. Not today, definitely. But the main thing is this is just talking about whatever array we're calling this method with. So whatever comes before the .replace, that's this. Okay. Oh, hey, Ange. Nice to see you. Okay, so what do we want to do with this? Well, basically we want to say if this at I is target, then this at I is going to be reassigned the value of replacement. Okay, there we go. And at the end, we'll just return, not input array, we'll return this. Okay, so that looks pretty much just like what we had down here, I think, right? Same sort of thing. So then we'll get rid of it. And we won't need that either. We'll just return input array dot replace. Let's see if that still runs. Oh, wow. Look at that. Okay, so that's another way of solving the problem here. And I'm just realizing maybe I should back up a little bit. So what did I have before? Yeah, actually, not that much. There we go. This down here, I think, that was our first algorithm. Yeah, there wasn't anything more to it. So let's run the tests again now. Yeah, okay, so this is another way of doing it. What's the better way of doing it? Not this. This is probably something we should not do. In fact, I found a piece of terminology for this. They call this monkey patching, apparently. The idea that we're putting in this additional method to an object that we didn't create ourselves. So this is like a JavaScript built in, and we're modifying it. We're modifying the prototype of an object that we don't own. And a lot of people will tell you that's something you probably shouldn't do. Okay, so we probably shouldn't do that. Let's get rid of it. I mainly just wanted to show you it is possible, but probably don't do this for objects that you don't own. And I guess I'll write that note. Probably don't do this for objects you don't own. Okay, and that's kind of strange. Like, I don't know if I like the wording there, actually. Objects you didn't create yourself. There we go. That's better. Here, let's make it more efficient. Built-ins. Yeah, probably don't do this for built-ins. For built-in objects. Okay, at this point, it feels like I'm going to spend more time just editing this comment than working on the actual algorithm. So maybe we'll just move on from there. All right, so we've looked at a couple options here. We found one of them is, I'll say, viable, and one of them was not, basically. Okay, so, but it illustrated an interesting concept, and that's kind of the point. Anyway, what we're going to do next is we're going to talk about this splice method. So if you remember, if we had an array that's maybe like -5, 17, 21, 0, and 9. Okay, so there's our array. And the way splice works, first of all, if we were to do a.splice, and we could have a few arguments here. So let's use 3 arguments for this one. So we're going to say first argument is going to be 1. The second argument is going to be, let's say, 3. And the third argument is going to be 5. There we go. And we'll see what that does. So first of all, when we run this, keep in mind, we're returning a.splice. So whatever the .splice returns, that's what we're going to get out of this. So we're getting 17, 21, 0. Notice that's basically just this middle chunk of the array. So let me explain why that is. We've used splice before, but just as a quick review, the 1 here, so the first argument, is going to be the index that we want to start at. So this would be index 0, this would be index 1. So I put the 1 here, it's going to start at 17. Now, unlike something like a slice, this second argument is not the index where we want to stop. It's the number of elements that we want to splice out of this thing. So by saying 3, I'm saying, yes, start here and also get 3 elements total. So get the 17, get the 21, get the 0. And that's the stuff that it's going to cut out of the array. So that's why we're getting 17, 21, 0 there. The thing is, it might not be clear what the 5 is doing, or if the 5 is doing anything. So I'm going to switch this around. We know what we're getting from the a.splice, but keep in mind a.splice is a mutating method. So now if we return a, then it should give us what's left over after we run splice. Okay, so notice we've got -5, 5, 9. And basically it's just taking this part, the stuff that we removed, taking out the middle of the array, and it's just replacing it with this thing. So the third argument, that's the thing that we want to stick inside of the array after we're done. Okay, so basically a.splice. In fact, let me console log this so we can look at both these at the same time. Yeah, ATD, you think it was all the algorithm slaying? Some algorithm got slayed, that's for sure. But anyway, okay. -5, 5, 9, and then the console log, we've got 17, 21, 0. So that was the thing it's removing, the 17, 21, 0, starting at index 1, removing 3 elements, and replacing those elements with 5. Okay, so that's what's going in instead. Instead of the 17, the 21, and the 0, we just have a 5. Okay, great. So, why am I talking about splice? Well, mainly because we could do something like this. Pick any index, let's go with 3, so this element would be index 3. Let's say we want to cut out one element from it, and we want to put in some other element. I don't know, I'll use a string actually, replaced. Okay, so basically with this, what I'm trying to say is I want to take the element that's currently at index 3 and just that element, and I want to replace it with the string replaced. So notice it's the same array that we started with, except now instead of the 0, we have replaced. Okay, so I'm going to use that. I'm gonna put all of this to use. In fact, I'm gonna keep this on screen for now, and I'll just write the next algorithm below this for now. So we'll do something like this. We'll say while, so we're gonna use a while loop here instead of a for loop. And the reason is because there's really only one thing I wanna check. While input array dot includes our element to replace. So as long as there's an element to replace, we want to replace it. How are we going to replace it? Well, we'll say input array dot splice, and then here's where things get a little interesting. What is the index of the element that we want to replace? Well, let's find it. So we'll say let index be assigned the value of input array dot index of element to replace. And we're using an includes here. I've been kind of on the fence about includes. I mean, I like it a lot more because it's more semantic, but technically I think this is a lot better supported. I'm pretty sure you're not supposed to use includes in production. So I guess we'll stick to this index of stuff. I think includes is probably sort of like the direction it's going to be moving in ultimately, but yeah, we'll use this for now, I guess. And then we're saying index is going to be that actual index of the element to replace. Okay, so, all right, while it still has that, we're going to make that replacement. So we're going to say wherever it is, make this happen. So we're going to do our splice at the index, wherever it is. We're just going to take out that one element. What are we going to put in instead? Well, substitution element. That's what we're trying to put in there, right? And then at the end, we've done a bunch of splices, and those will modify input array. So we should be able to just return input array. Okay, so this is basically how it's working. Keep in mind, splice, index of the thing we want to modify, how many elements do we want to take out, and what do you want to replace them with. So we're going to replace whatever's at the index of this, so index of element to replace. So in other words, we're replacing element to replace, and just that one element, we're replacing it with substitution element. Let's see what happens when we get rid of this and try running this thing. And looks like it passes all the tests, so that's nice. What if, just for comparison, what if we didn't have it in the while loop? What if it was just these two lines here? Like, could we just splice it the one time? And no, like if we do that, it'll just replace the first one and then say, oh, okay, I did a splice. So we do need to sort of keep it going by saying, well, while there's still an element to replace in there, and keep in mind, this might fire 0 times. Like we might not have that element to replace. Like, I don't know if they gave any examples like that, but no, I guess not. But you know, it could be something like, we'll make a custom test. Yeah, we'll say 1, 2, 3, and the element we want to replace is 4, and replace it with a 5. And so what we should get back is just 1, 2, 3, the same array that we started with. So let's try running that, and we'll see if it works here. Yeah, it works, because it's basically just never going to actually execute what's inside the while loop. It'll loop 0 times. Okay, great. So is there a way we can improve this at all? Well, like, I like the idea of grabbing this index and then using it down here. I mean, if we wanted to make it look a little more efficient, I guess we could like just take this and replace the index down here with all of that stuff. But I think in some ways that might make it look a little messy. So there's something I do want to try here. I actually don't know if this is going to work. And even if it does work, I don't know if it's a good idea. But since we've got this index here, can we do something like this? Index is assigned the value of input array.indexOf element to replace, and then not have to do that here. Like, would it already know what we're talking about when we get to this point? I wonder if this is going to work. I'm really actually not sure. Did that just run? I can't tell if that ran or not. Let me run the test again. Yeah, because like I said, I don't know if this is going to work. It does. Okay, so that's good to know, but there's a problem with it. Notice index is in green right now. Oh, and by the way, before I go any further, I just want to say, like, the reason I wanted to do this, the reason I wanted to put it up here is because, like, we're checking the index of element to replace. And then right after doing that, we're checking it again. So it seems kind of silly to me to have to do that twice. So that's why whoops, wrong direction. That's why I put it up here. But the problem now is, like I was saying, it's green. That's because it doesn't have a let, it doesn't have like a var, it doesn't have anything ahead of it to indicate that it's not a global variable. So right now this is a global variable. Not only would I be able to access it outside of this while block, like down here, I could say, yeah, return index. But furthermore, I could even access it outside of here, which is really not good for the security of your code. So could I just pop a little let in there, let index, and then, you know, that should go orange and that should go blue, I would think, but maybe it's not working that way. Maybe I can't have the let in there. No, it doesn't like that. It's saying that's an unexpected identifier. So maybe what I'll do then is I'll just identify it, or I'll declare it out here, let index, boom. And now they're turning blue, and we'll execute that. And yeah, okay, so that still runs. Now, I was told a while back that we don't want to declare a variable without assigning it. I don't know if that's like a hard rule or anything, but it's something that someone recommended. I'm just going to say equals -1, or sorry, is assigned the value of -1 to begin with. So why -1? Well, I mean, I figure if this assignment, for whatever reason, if this doesn't work, you know, if it's yeah, if that doesn't fire, it'll already be -1, so it won't go through the loop if it doesn't have to. I don't know. We'll just do that for now. And yeah, okay, so I kind of like that, I guess. I kind of don't like it at the same time because this feels a bit sloppy to me, the idea of it assigning this. So, is there another way we could do that? I don't know. Maybe like a loop within a loop or something like that. Maybe what the loop should do... Damn, I don't know. Like maybe the loop, like the while should be something like, yeah, okay, I have an idea. What if it was something like this? So let's get out of there and we'll say while true. So if you've ever seen something like that before, it goes forever. While true, basically it's always true, so it'll always loop, it'll always keep going. Okay, and then we'll say index. And since we don't have to declare it outside of the loop now, let's not. So we'll say let index. Okay, so while true, basically do this forever. Let index be assigned the value of that. So it's finding the index. And then it'll say if index is greater than -1, then under that circumstance, do this. Okay, and else, if it's not, break. And why break? Well, number one, break, just to remind you, is something that's going to get out of the loop. So this right here, while true, this is a loop that never ends unless it sees the keyword break. Okay, so let's make sure everything's right here. So we're saying our index is going to be the index of our element to replace. And maybe it has that element, maybe it doesn't. If it doesn't have it, then index is not going to be greater than -1, so we should break. If it does have it, then we should do a splice. And because we're not breaking, that means it'll keep the loop going after that. So let's run this. Let's see if this works. And it does. Okay, so yeah, I would say I like this better. The way we had it before felt a little more like kind of code golfy, you know, it felt like we were trying to do too much all at once. So yeah, I like this better. I think this is nice. If for whatever reason it didn't get to the break here, we would have an infinite loop on our hands. So I don't know, we could do something to avoid that. Like, for example, we know that we know that this shouldn't have to fire any more times than the length of the input array. So we could say, like, for let I be assigned a value 0, I is less than input array dot length I plus plus. And the only reason we would do this is to make sure that the loop will terminate, just in case for whatever reason this part doesn't work. So this is kind of just like a safety mechanism here, but we're probably fine to just do a while true. The reason I'm doing this, because you might think like, well, why would we have to check this if we already know that it's going to hit the break eventually? Well, you know, this is how you open yourself up to hacks. And oh, yeah, that's what I'm talking about. Okay, thanks, codefights. All right, so basically what I was saying is that's kind of how you open yourself up to hacks or attacks like that. It's by making assumptions or relying on assumptions, by saying, oh, well, of course we can put a while true up here because it's gonna break eventually. Well, what if for whatever reason, you know, someone managed to get into your code in such a way that it didn't return a false for this at some point, you know, for whatever reason. So we just want to be kind of prepared for that. We want to have this as a safety mechanism. I mean, look, it's not like this is a super unsafe algorithm in any way at this point anyway, but it's just one of those things, you know, we don't want to rely on assumptions or anything like that. Okay. So let's see, what have we done? We've done 1, 2, 3 algorithms so far. And this one's pretty good. I think I like this one, but maybe there's one that I like even better. Okay, so yeah, it's probably a good amount of spacing. This is going to be our final attempt for this one, and it's going to be the most brief. So I know some of you guys like array functions, maps, filters, that kind of stuff. So that's what we're going to use here. Now, this is one where we're trying to return a new array that's kind of similar, like same shape and size as the original array, except we're doing some modifications to each entry, potentially. So that is like a classic map situation. We definitely want to use a map here. So our input array dot map. And then basically the function inside the map is something that's going to say, all right, well, whatever element you've got, so we'll just call it X for now, is X element to replace? And if it is, give us substitution element. If it isn't, just give us X, whatever it was to begin with. And let's just move that over a little bit so we're not bleeding onto the next line. Let's give that a quick run, and wow. Okay, I think I like that the best, maybe. Maybe not though, because, okay, I'll tell you what I don't like about it is the fact that this is going to go through every single element regardless, right? Whereas down here we could say, well, how many times is this loop going to fire? Only as many times as element to replace appears in the array. So if there was only if the array could be 10 elements long, but there's only one instance of element to replace, well, this isn't going to take very long. It's only going to go through once. Then again, just doing index of, wouldn't that have to go through the whole array anyway? So, yeah, probably this one's best. I don't know. I think it's pretty good. I think it looks nice. It's nice and clean with the ternary in there. So, all right, that's probably enough, I would say, for this problem. We've got sort of 4 different ways of looking at it. And keep in mind, I mean, this wasn't a super complicated problem to begin with. I mean, we've definitely had more challenging ones, but it's nice to sort of look at all the ways we can sort of approach something that's a little more basic like this. So that's nice. All right. Any questions, comments?